I've been given this sketch here for the function f of x. I'm being asked to sketch f of 2x and f of half of x. Where the common error for this is with f of 2x is to say it stretches it by 2 in the x direction. This is incorrect, because actually what we need to do is to stretch it by a half in the x direction. So the curve becomes, of this first one, this point here of 4, 0, moves to 2, 0. The peak here of this section of the function 2, 2 becomes 1, 2. And so this bit here looks like that. This section of the function, negative 2, 0, becomes minus 1, 0. The peak here of minus 1, 2 becomes minus a half 2. And so that here is f of 2x. For the second part of the question, f of half of x stretches it by a factor of 2 in the x direction. So this point here of 4, 0 moves to 8, 0. The peak here of this section of the curve 2, 2 moves to 2, 4. And the curve sort of stretches out here. So this becomes f of a half of x. And then turning to the other side of the origin, negative part, the negative 2 becomes negative 4, 0. The peak here of minus 1, 2 becomes minus 2, 2. And so it now looks like that. So this part here is f of a half of x. So the common error is to be a little bit confused. The 2x translates it in the x direction by a scale factor of half. The f of half of x translates it in the x direction by a scale factor of 2.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.